Having installed the dependencies, now we move on to data and folder structure. So when we say we want to have custom object detection using YOLO, what we need is data. So what are the data that we want to make object detection upon? So first we need data, and then we will have to arrange those data in a particular structure for machine learning model to adapt to the data and make detections. So let's look into the data first. So this is our base folder. So we go to base folder, and in the base folder we make three folders: um, train, val, test. So train consists of our training data, val consists of our validation data, and test consists of our testing data. And we will see how to make use of this. So inside the train we will have again two folders: images, labels. So and then we replicate the same thing for val and test. So our base folder has three. If you go to again our base folder, it should consist of three folders: train, val, and test. And inside each of these folder we have images and label, and then we will populate all these things with our images that we want to make detection upon. So I already have some data. So I already have some data here that consists of vehicle detection data set, uh, and then this vehicle consists of some vehicles, like there are 1254 data. So this consists of vehicles for, and there are different types of vehicles. For example, this is a truck, ambulance, again ambulance, truck, ambulance, bus, motorcycle. This is a car, motorcycle. So these are the things that we have here. So out of these things, now let me put it side by side. So this is our source file, I mean source images, and we want to put it in our train. So on the right we have our source images that consist of 1254, and we want to, and this is your data set, and we want to put this data set in a particular folder structure. For example, we want to put it in train, we want to put some in test, and we want to put some in val. So normally what you do is that you have like 80 10 10, 70 20 10. So that means 70% of the data goes to train, 20% to validation, and 10% to testing. So we will split into 70 uh, 20 and 10, sorry, 70 20 and 10. So 70% of this 1254 is approximately 878. So what you do is that you choose 878 of these images. So for example, so you choose 878. Yeah, so we have chosen 878. So you see, out of 1254, 878, that is approximately 70%. So we choose 70%, we cut it. So we cut it, and then we put it in train images, and we paste it. And now so now what we have is that we have our train folder. Inside train image you have 878 images. So similarly we go back to val folder, and then choose 20%, that's approximately 250. So if we choose 250, sorry, yeah, so from here we choose 250. Yeah, so we chose 250, cut and put into val images, and we are left with 126 images. So then we select all and put it in test images. So this is how your folder structure looks like. So your all data set that was here was transferred to so all the original data set that we had is transferred into train test and val. So train consists of 70% of your data, that's approximately 878 items, and then we have val consists of 20%, that's 250, and test test images has 10%, that's 126. So normally you do 70, 20 and 10 split. And so once we have this train, and then we have images, and then we have these labels. So now we will use our labeling in the next tutorial, in the coming tutorial, that how to label the image using cvat. So then we will populate this label. So the idea is, for each image that we have here, we will have a corresponding labels here. So and then we will have our training and validation and test, and similarly we will do for all of them, train, test and val.